Hello, my name is Sahmet. I'm one of the manufacturing engineering designs for this project.
Hello, I am Sahmet Patel. I am the main designer of this project.
Hi, my name is Edelson Becco, and I worked on the electrical components on this project.
And today we're presenting the Mothership, which is the high deployment system.
All right. So the high deployment system is a system that we designed to drop small drones off of a larger drone in order to use for surveillance or search and rescue in any application. This right here is our final prototype. If you want to come in a little bit. So what we have here is an acrylic plate holding onto the main body of the drone with two stands. These two stands have two rails and a lead screw. And on that lead screw is this component right here, which is a moving nut that will slide this drone back and forth, leading it to be going towards this right here, which is a pusher mechanism that pushes this pin, which is very hard to see. It looks like this. It'll push that out, dropping this drone. Now, this is a proof of concept. Obviously, for a system like this, you would want to be able to drop multiple drones. And luckily, this is designed in a way where you can extend this lead screw and just change this acrylic plate to be longer to add more drones in a row, which is great for modularity.
In addition to, we also added our legs to extend to give space for the drone and the mounting system, because without the legs, it'd be a little too tight to the ground. So we just printed 4 sets of 4 legs, just so it can fixate and hold it up the drone. And that's about it. And then we can start demoing the project.
So I have the motor connected to the Pixhawk 4, which is connected to the remote here. And so I have it configured in such a way where by flipping this 3-position switch, I can have the lead screw go either forward or backward. And so here's a demonstration of it dropping. Sweet.
So right there was our live demonstration of the little drone right here falling off of our system here. We are currently using a demonstration motor. The current motor that we're actually going to use is not here right now. So with that, we can go into some of the challenges we faced while dealing with this project.
One of the major problems we had is creating the pin drop mechanism. So for the pin drop, we had a lot of ideas of saying how we're going to get this drone to actually drop when mounted onto the actual drone itself. We tried going with the pen clicker type of joint that we experimented a lot, but it failed and broke a little bit too much because PLA was very brittle and it snapped right off. And we created this annular snap fit joint. This was created on a first print and it worked the first time, and essentially held onto the drone perfectly by using frictional forces and gave a tight seal with it. So now when we included it into a thread nut, as you saw before, it held on perfectly and just held onto the drone and had enough friction where it was able to release it by, as you saw through the video, by just a simple push. And so the fact that we got this on our first try, it excelled our project into moving on to the next steps of actually assembling the whole thing. So the next issue that we had was the motor that Edison will speak about.
So the first motor that we had was a DC motor, which when we tested it on the system itself, didn't have enough torque to rotate the lead screw to push the pin out and release the drone. So I immediately had to source a different motor. And so the next one that I sourced was actually the incorrect one. It was only able to rotate 180 degrees, and that was not what we were looking for our project. The next one that I found was a higher torque motor, which worked, but the torque was so high that the speed was so low. So it took a really long time for the lead screw to actually push the drone and get it to fall. So I improvised and got a smaller motor that functioned at a higher speed, which is what you saw on the demonstration. At first, I was trying to get an Arduino Nano to spin that DC motor and have the Pixhawk send a digital signal to that Arduino but I was having issues trying to get the actual Pixhawk to send that digital signal to activate that motor. So I was trying to find alternate ways to incorporate the motor into our project. And so that's when I came across a YouTube video that basically demonstrated how a servo can be incorporated within the Pixhawk 4. And so that kind of led me to choose that different motor, the servo motor. And initially when I had the Arduino, I had a radio that was independent from the radio that was used with the Pixhawk 4. So it required additional components, and so moving to the Pixhawk just powering the motor, it helped a lot by eliminating all the extra components needed, such as the radio, the Arduino, and mechanisms in between to get that motor to function. So right now the motor is just connected to the Pixhawk 4 and using pulse width modulation to activate the motor.
Our next major issue also was our availability of makerspace and 3D printing. So we began printing nearing, I want to say, the end of October, getting into November, where the semester started picking up, where projects were starting to meet deadlines with other students. So the availability with printing was very difficult to try to manage, because almost every time I tried to go printing during that time, printers were taken and I would have to wait. And then it came again where the Ultimaker printers were failing a lot. I remember there was one time where I had to stay for 3 hours to try to get a print going on. So just to get around this problem, I had to essentially come to Makerspace at 9 a.m. in the morning, 10 a.m. in the morning for, I want to say, about 2-3 weeks straight, just to get a print going on and just a prototype fast and easy. So, and again, a solution would have been to this was prints should have been done earlier in the semester to avoid this issue. And then minor problems, excuse me, there were also minor problems along with this, which is just 3D printing tolerances and then just general availability due to the semester.
So to work on this project, we had to definitely look into a lot of different resources. The idea of using a lead screw right here was first brought up by Sahmet, and it was a YouTube video that he had seen where the screw was driving something forward, and we were like, that's perfect, that's what we need. We need something to function in a singular motion using very low parts in order to prevent the battery of the drone to be changed, overused,
Yeah.
stuff like that, right? So we ran with that idea, and with that we went, okay, now we have to figure out how to hold the drone, make it drop, stuff like that. But that's when we started looking into different patents, different ideas. I looked into a pen system for drop-in mechanisms. We ran with those ideas for a bit, remembered that 3D printing, the parts are very brittle, so it was very hard to use those parts because it required the part to be flexible. Then we ended up with the current design, which a snap fit annular joint, which was great because it was very simple, didn't have to design too much around this, and everything worked the first time, so we were happy with that. Looking at the little drone real quick. So we had to grab parts off of GrabCAD because we didn't have the dimensions of every single thing on this drone to attach to the larger drone. This piece right here, most of this casing was found on GrabCAD. We did slight edits to add this mechanism right here to hold the drone into the nut. Another piece that was found on GrabCAD is this bottom plate for the drone. We use that to offset the acrylic cuts that were required. And overall, any resources that were required, we either talked with the professor or used GrabCAD or YouTube to find solutions for. So that will lead us to anticipations.
So at first, like I mentioned before, we anticipated using the Arduino and a DC motor to basically run the electrical components via the Pixhawk 4 to send the digital signal to that Arduino via the controller. but I was having a lot of issues trying to connect the two and have them communicate with each other. So that idea kind of got scrapped in favor of just running the motor off of the Pixhawk 4 and getting the remote itself to just activate the motor.
So major areas where we experienced discrepancies from what we anticipated was the total weight of the mount, because we initially thought that if we had too much of a payload on the drone, we would have to change the battery, get a larger battery, which would increase the weight, which would cascade into us constantly having a problem with the overall weight constraints of this drone. But luckily, once we started working on it, we realized it will not weigh that much. Like, if I lift this up, there's like barely any weight added with the mechanism. And even with the drone added with the full batteries, it barely increases the overall load of the drone. So that was very nice.
And then again, another discrepancy that we always fish was, again, referring back to the pin system. There was times where Sam and I were discussing, saying, how are we going to get this drone to actually drop? How are we going to get this payload across with it going through the pusher and actually get to drop? So we had come up with multiple designs, multiple different ways of approaches of going about this, until we finally got through this problem by figuring out using a snap fit annular joint on the first try. So once we actually were able to get through this part, the project excelled, and we're able to follow up with the creation of the mounts, lead screw, and the threaded nut itself. So it actually progressed really fast, because we really did expect this to take a while to try to get this release mechanism working, but since it worked on first try again, we were able to push forward.
A little bit more on that. We did not decide to just use this out of nowhere. We were thinking of using a locking mechanism on top of this,
Oh yeah.
right? And that was our initial idea. We thought, okay, let's just print out this initial piece, see how it fits, and then add a locking mechanism. But we realized we didn't need that locking mechanism at all once we put it in and noticed that the drone would not fall out even if we shook this nut down here. So that was a happy little accident.
Yeah, no, seriously. And I remember too, when discussing with our advisor, he asked how many times did this take?
Yeah,
And we said it first try.
first try. Greatest part of our discussion with the professor.
Seriously.
So the way that we resolved some of these issues, for example, eliminating the Arduino and the remote system, limited the weight that was put onto the drone, so that helped that factor. And like I mentioned before, the motor is running off of the Pixhawk 4, which is controlled by the controller here. And so that kind of makes it very intuitive to use. And we also did a lot of trial and error with the prints. There were many iterations which we improved upon. These are just some examples of prints that we used in the beginning to test our designs. And so ultimately we got everything to work in sync with each other and ended up on this design here.
Yeah, so that concludes our presentation of our project. We worked really hard on this, and we're happy that it works properly. And if we had more time, I think we would have set it up so we could have 2 drums, or at least 2 displaying on it. But the proof of concept works, and I think it's amazing. Yeah. Anything else?
No, everything was good.
Yeah.
We would like to thank the class and the professor for giving us the opportunity to work on this project. We had a lot of fun making it, and we collaborated pretty well with each other, and we learned a lot doing this project.
All right. Thank you.
Thank you.